So the equation that you have to remember is the quantity of electric charge let's measure in coulombs equal to current in amperes times time in seconds, alright? So it's basically Q is equal to alright, so that's mainly physics, alright? Alright, now, so the Faraday constant and 1 mole of electron is equal to so that is 1 mole of electron to discharge ion with a single charge, alright? Alright, so if you right. So in the reactions that we were doing earlier, for example, to discharge say 1 mole of hydrogen gas, you would see that it's 2 moles of electrons would be required if you check back those equations. Alright? So it simply means that for each mole of electron, the quantity of electric charge will be 96,500 coulomb. So if you should have like 1 mole of metal or anion and it requires 2 electrons to discharge the mole, then you would actually have to multiply this by 2. Alright? Alright, the time is also in seconds, right? So if we give it in minutes, you have to multiply it by 60. If you get it in hour, you have to multiply it by 60 times 60. So hour is 60 times 60 to convert that to second. If it's in minutes, it's 60 times the value to convert it to seconds. You have to get familiar with those minor calculations as well. Alright? No. And if we are doing gases, the volume, we have to know whether the volume is at RTP or STP. Alright? So remember that Avogadro's law. One mole of any gas volume of 24 dm cube or 24,000 cm cube at RTP, room temperature and pressure, or 22.4 dm cube or 22,400 cm cube at STP. So if you have gases in the mix, you can remember that with quantitative electrochemistry, electrolysis, they will ask you like, what volume of gas will be produced if XYZ current is applied for XYZ time. Alright? I'm going to work an example and try and wrap up, alright? But some of you just leave it blank. Alright, so question. So this is page 5 and I'm going to look at number 10. Alright? So a current 8 amperes what volume of oxygen gas measured at RPP would be produced, alright? No, so first thing, let's write the reaction. So the anode is the positive electrode, right? And it states what volume of oxygen gas. So we know it's the hydroxide ion over the sulfate. Hydroxide ion is at the bottom, sulfate will be about the second, right? So the anode reaction is 4OH minus AQ. Produce 2H2O liquid plus oxygen gas plus 4 electrons. Alright? No. So it simply means from this, therefore, 4 moles of electron required to produce 1 mole of oxygen gas. We can make that statement comfortable, right? Good. So a current of 8 amperes flows for 48 minutes, right? So remember that we need to calculate the quantity. So this is 8 here times, the time is what? 48 times 60 plus the 15, right? You're lost here or following? Because remember that I said before, if we have it in minutes, we have to multiply it by 60. If it is in hours, we have to multiply it by 60 times 60 to convert it to seconds. You have to remember that piece of conversion as well, because some students in the exam just don't have a clue how to convert it. Alright, so if it's minutes, it's multiplied by 60, but if it is in hours, you have to multiply it 60 times 60 to convert that to seconds, right? And you can see we're going to add the 15 seconds because it's 48 minutes and 15 seconds. So 48 minutes in seconds multiplied by 60 times 48, but we still have to add the 15 to it to get the overall seconds, alright? So 8 times, what's the value here in seconds? 48 times 60 plus 15. 95 seconds, right? So what's the Q here, stand for? 150? 60 coulombs, right? And this is amperes here. And this is seconds. That's the SI unit. So the SI unit for current is amperes and for time is seconds, right?
So that's not the final answer.
Oh, yeah, the final answer. Or just use A here. I believe. Sorry. Let's put the A. Alright? Amperes, just A, right? And that's second. Alright, so take this and move on, alright? Remember that they want the volume of oxygen gas. This is just the quantity of electricity that was used, right? Now, so it simply means that for 1 mole of oxygen gas, we would need 4 times 96,500 coulombs. All following, right? Because it's 4 moles of electrons would discharge 1 mole of oxygen gas. This is equal to 40. Right? Good. Alright, so we can say here that safe to say based on mole concept principle that 386,000 coulombs would produce RTP or STP, what's it again?
RTP.
RTP, so it would be 24 dm cube of oxygen. That would be 1 mole of oxygen, right? Because it's 4 moles of electron required to produce 1 mole of oxygen. It's very complex, but they have to do it over and over to understand, right? Mole concept principle, therefore 23,160 coulomb required to produce X dm cube of O2. This is at RTP. That means that this would be X equal to 23160 times 24 divided by 386,000. This is the X here is the volume of oxygen. What's the answer here?
1.44.
This is in dm cube. Alright, so if we multiply this by 1,000, we get the answer in the cm cube. Alright? Then the next aspect of the question I'd ask one. What mass of copper would be deposited at the cathode? So here. Alright, so remember that the knowledge that you would have to have here is to know that you have to know the Faraday constant, so it requires 96,500 coulombs to discharge 1 mole of electron. Alright? To discharge an ion which have a single charge, which would require 1 mole of electron. That's the thing. So you have to actually balance the equation to know the amount of the moles of the ion that will be discharged based on the number of moles of the electron. Because it's coming from balance equation. Alright? So what mass alright, what's the cathode, right? What's the reaction taking place? Copper is 2 plus. Right? That's cathode reaction. Okay. Deposited. Is the question?
Deposited. So you forget to give them the test paper.
Oh! Please, I'm going to give you back. Test, you can give, I have test papers available to give you back today. Alright? One from last week. So you go home and you review. Alright? No. Remember that we already did the quantity of electricity. So remember that, oh sorry. So in this case, we would require 2 moles of electron to deposit 1 mole of copper. Based on this, right? So it simply means that we need 96,500 times 2. Mole of copper. Alright? So what's the value here that we multiply this by 2? What do we get?
193,000.
Alright? And since I asked for mass, we could even do the mass from here.
Copper 64.
64. So this statement is just made purely from understanding mole concept and Faraday constant. And the balance equation, of course. But 96,500 coulombs would be required to discharge an ion with a +1 charge. While 2 times 96,500 coulombs would be required to discharge 1 mole of an ion with a +2 charge. Because remember that the Faraday thing is strictly electrons, mole of electrons it goes by. Alright? Now, it simply means that what did we get for the quantity of electricity from the previous part? Because remember it's the same electrolytic cell. You know? What did we get for the quantity of electricity?
23,160.
X grams of copper. Alright? Two, 3, 160. And then this will give you directly to mass. Alright? If you want to do it directly to mass. But apparently we could calculate the moles and then convert the moles to mass. It could work just the same. Alright? If you understand mole concept, you will not be confused. Alright? So what do we get here for the mass?
7.68.